So in this short video, I will be analyzing the molecule methyl ethanoate. Okay, so to begin with, the functional group of this molecule is an ester, of course, and we know this because there are two oxygen atoms, and in which one of them makes a double bond, as shown. Okay, so let's start off with the bond angles. So the bond angles of this methyl is in fact 109.5 degrees, and which makes a tetrahedral molecular geometry. Um, so this carbon here is actually also methyl, even though it's connected to this other carbon, which makes the ethane. Although it is a methyl, it actually does make a 109.5 degrees bond angle, and is again a tetrahedral, has a tetrahedral molecular geometry. So this central carbon, or this ketone, basically makes a bond angle of 120 degrees and makes a trigonal planar molecular geometry. And then this other oxygen atom makes a V-shaped molecular geometry and has a bonding of less than 120 degrees. This is because basically the lone pair that is situated over here is drawn closer to the nucleus of the oxygen, and since the lone pair is closer to the nucleus of the oxygen, it will basically slightly push the two carbon atoms down out of the linear molecular geometry. Okay, so the hybridization that are in these two methyls is the sp2 hybridization, where they have 4 sigma bonds. Now this central carbon has a hybridization of sp3, and this is because there is a double bond here, which means there's a pi bond and a sigma bond. As the type of reaction that this molecule undergoes is nucleophilic substitution. I think we're done, mate. I don't think there's anything else to cover. Probably is, I don't know.